All right, guys, this is section 3.4, parallel and perpendicular lines. So there are three theorems that they introduced to us here. I'm going to show you how you would use them to do some algebra type problems, and then also how to use them to do some proofs. So I'll do a couple of first two proofs that I assign in the textbook I'm going to do with you as part of your notes. So when we get to that part, I'll let you know. All right, so I'm going to just kind of draw some pictures here. If you want to pause the video and then write down the theorems, and you can draw the picture to go with it. And I'm going to say a little bit about it. But theorem 3.8 says if two lines are parallel to the same line. Let me draw a picture of that. So two lines. So we have one line here, maybe call this line A. Another line up here, we'll call this line B. And then there's a third line that they are both parallel to. Let's put it in the middle, call that C. Then they have to be parallel to each other. It's kind of like the transitive property with congruence or equality. If this one right here is parallel to this one, and C is parallel to both of those, then they all three have to be parallel. So that's what that theorem 3.8 is saying. Once again, you can pause the video if you need to write down the theorem or to draw the pictures. Theorem 3.9 says in a plane, if two lines are perpendicular to the same line, so here are two lines that are perpendicular to the same line. So here's line A, here's line B, here's line, make it a line so it goes all the way through. Here's line C. They are both perpendicular to line A. Then they have to be parallel to each other. Because of these 90-degree angles here and here, they have to be parallel to each other. So B is parallel to C. So when you draw the picture, I think it's a little easier to see that it does make sense. We use this idea all the time without even knowing about it. We look at walls and rooms, and there's some problems that talk about rungs of a ladder. So there's a ladder going like this. If I shouldn't have made it, let's make it a better picture here. So I mean a ladder that goes straight up and down like this. These rungs are all perpendicular to the sides of the ladder, therefore the rungs are parallel to each other, things like that. So there's some problems in the bookwork about the rungs of a ladder, and that's the ladder that they're talking about. Same idea as this theorem 3.9. Theorem 3.10 says in a plane, if two lines are perpendicular to one of the two parallel lines, so if two lines are perpendicular to one of two parallel lines, so here's a parallel line, here's another parallel line, and it says if two lines are perpendicular to just one of them, so let's say it just hits one of these guys at a right angle right here, but the line continues through in that same fashion, it's going to also be perpendicular to the other. Same thing here. If it were to continue through, it would make another right angle there. So those are the three theorems dealing with parallel and perpendicular lines. And we're going to be doing a little bit of proof, some algebra equations with it, and a little bit of kind of real life sort of scenarios you're going to look at. So we're just going to do one example, well, two parts of one example, where we have perpendicular lines. Perpendicular lines create 90-degree angles. That's what this box right here means. So if I have two perpendicular lines and I'm given an algebraic expression for one of them, then I know that x squared plus 9 has to equal 90 degrees. The fact that those are perpendicular lines means they make actually 4 right angles here, all the way around. Solving this for x, if I subtract the 9 over, I get x squared equals 81, and then I take the plus or minus square root of each side. So I've got plus or minus square root of 81, which equals plus or minus 9. And if you check it, negative 9 will work in the original. Negative 9 squared is positive 81, and 81 plus 9 is still 90 degrees. So you'll be setting things equal to 90 in this section instead of 180 or each other as much. In the second example, I know that these two angles, because these lines are perpendicular, must add up to 90. So this is really just a matter of subtracting 62 from 90. Here's the algebraic setup. Subtract 62 from 90. And we've got x equals 28 degrees. So there'll be a little bit of algebra to do with perpendicular lines there. All right, there's also some questions that ask about some things that have to do with construction in your assignment. So here's an example of that. We've got, suppose you plan to install molding on the sides and top of a doorway. So picture a doorway in your house. Look at the doorway in your house. You'll see some molding pieces at the top and at the sides that look kind of like these, most likely. You cut the ends of the top piece and one end of the side pieces at 45 degrees as shown. So right here is 45 degrees. Right here is also 45 degrees. Will the side pieces of molding be parallel? Well, when you put those two together, the two 45s together, make one single 90-degree angle right there. And then on the other side, when you put this 45 together with this 45, you've got another 90-degree angle over here, which guarantees that the sides will be parallel. So that's an example from construction. Have you ever done baseboards or molding around a door, a window? You kind of use that theorem that has to do with if two lines are perpendicular to the same line, they are parallel to each other. All right, so that's it for the notes. Make sure you have these two examples that I did and the theorems also all written down. You can go ahead and pause the video if you want right now. I'm gonna move to the homework. If you want to label, go in Google Classroom, look it up, label your homework. I'm gonna do the first two problems with you from the homework. I have them right here. This is right from the textbook. This is problem number 7. Actually, I think I assigned 6 as well. 6 is the construction example, like what I just did. But 7 says developing proof. Copy and complete this paragraph proof of theorem 3-8 for 3 coplanar lines. So we are going to fill this in. You can pause the video if you want. Go ahead and copy it. I'm going to just keep moving on. But this is kind of the idea of the transitive property of parallel lines. We're given that line L right here is parallel to line K right here. We're also told that line M right here, let's do a different color, M is parallel to line K as well. And so if both M and L are parallel to the same line K, then L and M must be parallel to each other. That's the big idea. Okay, that's what theorem 3.8 says. So we're going to prove that theorem, not use it directly, but prove why it works. So we have, as a proof, since L is parallel to K, angle 2 in our picture is congruent to angle 1. So angle 2 is congruent to angle 1 by the corresponding angles theorem. So corresponding angles are always congruent when the lines are parallel. So corresponding angles theorem. Then it says since M is parallel to K, so since M is parallel to K, something is congruent to something. So since M is parallel to K, we can say angle 3 is congruent to angle 2 and 1. So 3 is also congruent to angle 1. So angle 3 is also congruent to angle 1 for the same reason. By the transitive property of congruence, angle 2 is congruent to angle 3. So you notice here we have this statement here and this statement here. When you put those two together, that's the transitive property. 1 is equal to 2. 1 is also equal to 3 right here. This is angle 3, angle 1. Those are each congruent. And so 2 is congruent to 3. By the blank theorem, L is parallel to M. So since 2 is congruent to 3, it's the corresponding angles, or Remember, it's converse theorem because we're proving lines are parallel, and that's it. So that's the proof of 3-8. All right, pause the video if you need to finish that up, filling in the blanks for that paragraph proof. All right, number 8 says write a paragraph proof. So paragraph proofs can be just some sentences. You're not doing a statement and reason table. You're just doing some sentences, maybe drawing pictures and diagrams to go with some phrases. It's pretty open-ended. It says given in a plane, A is perpendicular to B is perpendicular to C, and you have a picture over here. And C is parallel to D. So notice that C is parallel to D. You can see the little arrow marking there and there. We're going to prove that A is parallel to D as well. So as I look at this picture, let's go ahead and get the ink off of this. As I look at this picture, based on the given, I have a couple of lines perpendicular to the same line. And so if I'm going to prove A is parallel to D, I can say, well, I can't change the angle that B hits A or C. It's going to just keep on continuing through at that same angle. And so what's going to happen here is that when that continues on, I'm creating yet another right angle, okay, or another perpendicular right there for D. So what we have, if you go back up here, we've got two lines perpendicular to the same line, one line parallel to another. What does that sound like from our theorems in the very beginning? So we've got in a plane, if two lines are perpendicular to one of two parallel lines, then it is also perpendicular to the other. That sounds like theorem 310 to me. So in a plane, if two lines are perpendicular to one of two parallel lines, so go back over here, we've got two lines here and here, perpendicular to one of two parallel lines, then it is also perpendicular to the other. So back over here, to one of two parallel lines, we're talking about the parallel lines C and D. It's perpendicular to C, and so it has to also be perpendicular to D. So that's by theorem 3-10. So by theorem 3-10, B, line B, must be perpendicular to line D. And then I have this whole string of perpendicular line segments now. Let's draw this in. So I've got basically A is perpendicular to B, C is perpendicular to B, and also D is perpendicular to B. And so since both A and D, we're just looking at these, A and D are perpendicular to the same line B, so since A and D are perpendicular to line B, they are parallel to each other. So to review here, what we're saying is that this line that's perpendicular to one of the lines that's parallel to D, it's perpendicular to C here, it has to also hit D at a right angle. Since this line D is perpendicular to B and this line A over here, that's a different color, A and D are perpendicular to the same line B, they must be then parallel to each other. That's it. Two sentences and a picture over there. And those are problems 7 and 8 from your homework. So please start on the homework. Once you have the notes, you'll be turning that in on Google Classroom. This is the 3-4 homework. Thanks for watching.